transfer the reflecting surface at V because it has to be at the vertex. Okay, so let's remove some parts. Okay, what else? Okay, so this is the orientation of the ray diagram for convex mirror. Okay, so the vertex and the center of curvature are swapped, and the reflecting surface is relocated. So it still has to be at the vertex. Okay, and as you compare this with the uh, ray diagram for concave, you can see it's like uh, what do you call it? Flipped. So the ray diagram is like flipped. Okay, so that's the difference. Okay, but the way we and also the way we do the ray diagram is slightly different. Okay, for convex, so let's say this is the object. So the object is placed somewhere in front of the mirror. So there's no any other cases, but only one case for convex mirror. So the same thing, you draw sets of light rays from the head striking the mirror. So let's draw that light ray from the head to the mirror. For the reflection, we before you do the reflection, you try to draw a line projected behind the mirror, and that line has to be passing the virtual focus. Virtual focus because it's behind the mirror. Okay. But the actual light ray is this. So as you can see, it's like spread out or diverge. Okay, and this is what you have to consider, guys, when doing a ray diagram. Because the projected line behind the mirror is just imaginary.
Huh?
This one. Uh, yes. Any question? All right. Is there any question? I think I heard somebody. Okay, no question. All right. Now, since the line behind the mirror is just imaginary because this is a non-existing ray of light. The actual ray of light is here outside and it is diverged. So to represent an imaginary line, you will be using broken line. It's similar to how we present imaginary lines when you are doing a cartographic sketch in fine arts or architecture. So any imaginary line projected is represented by a broken line. Okay, so you will be doing the same here in physics. Okay, actually, it is also applicable here in plane mirror. This line projected behind the mirror has to be imaginary. Okay, but I was in a rush here, so I wasn't able to show it. But this has to be imaginary because they are non-existing light rays, but they are just projected in a schematic representation. Okay, so let's go back here. Okay, so that's your first light ray. So this is the incident ray, this is the reflected ray. Okay, now how about the second set? For the second set, you are also to start at the head of the object, and then you project that line but not crossing the focus. This time it will be crossing the center of curvature. Okay, so that's the second. And but the actual light ray is this, the one that is spread out or diverge. So this is the actual light ray. So as you can see, the light rays are diverged out, okay, or spread out because of the curvature. But since this projection is just imaginary because they are really non-existing, so you use broken line to represent them. So in your activity or exam, Using solid line here is already a deduction to your point, huh? So be careful. When you are doing imaginary line or light trace or light projection, you use broken line to represent it, okay? Otherwise, it will be marked wrong. Now, if we try extending the diverged light, okay, in front of the mirror, are we gonna have any point of intersection? So let's say we try to keep extending it. Do you think they will meet at a point? The two reflected rays? What do you think? To meet at a common point? Okay, well, obviously, that's impossible because it keeps spreading out. Okay, so there's no way these two will meet at a common point. But could we generate a point of intersection based on this diagram? And if it does, uh, could you mark it or annotate it? So anybody, where is the point of intersection? Okay, Jaya have identified it. Yes, it's this as the point of intersection. Okay, so let's mark our point of intersection. Uh, Wait, guys, give me a few minutes because I need to uh, go for a while to my SMP class. Your classes with SMP are overlapping. I have so many conflicts. Okay, I just give instruction to them for a while, huh? Because they are now entering the Zoom meeting. Okay, sorry guys, the office needs to fix the schedules. It's because of the offline classes of SMP. Wait, I'll just give instruction to them. Okay, wait first. Okay, I think we can already continue. Wait. I will just review my message to them. Before the shooting for Okay, I think it's just okay. So let's continue. Okay, sorry for waiting. Huh? By the way, the screen is still visible in your
Sure.
monitor.
Yes.
Okay, okay, good. All right, so let's mark the point of intersection. So this is the point of intersection, and from there we draw the head of the image and also the body and the tail touching the principal axis. Okay. Now we try to draw conclusion out of this. Okay, in our line group, please enumerate the the description of the image in terms of the following. Okay, anybody? Try to enumerate in our line group. So arrange it according to what I told you. Starting from the type, size, and then followed by the position. Make it complete. The tree, based on the tree. Okay. Jaya already suggested virtual. Okay, uh, here's how we describe the image form. Okay, so it's virtual, yes, because it is formed behind the mirror. So since it's behind the mirror, then there's no way it will be projected in a white screen. But let's say you put a screen in front of the mirror, this will not be visible there, okay, because it is virtual. Next, um, the size is smaller than the object, okay. And finally, the position is erect, or you can also use the word upright. It means it is similar to the object. The direction is going up. Okay. So this is how we do the ray diagram for convex mirror. Now I will be posting activity on your Google Classroom. So you will be doing it as an assignment. We will not be doing it next meeting anymore because we have to rush our lesson so that we can proceed to the calculations involving mirrors by next meeting. Okay. So once you receive your activity later after your classes, you may start doing. So I am going to post a file. It's a Word file. It's either you do it directly in the Word. If you can draw, you can insert lines or drawing in Word, right? So you can directly draw it in the Word and then save your file and you will be sending it in the Google form that I will be posting in the Google Classroom. I think it's yeah. So I think it can you can also insert file in the Google Classroom. Yeah. So I will be attaching a Google form. I mean, and you will be inserting your file there. Okay, so that it will be easier for me to check when it is in a Google form. Okay, so any question, guys? Ending you this lecture so you can
Not as of now,
continue.
teacher.
Uh, all right. So you may now prepare for your next subject. Goodbye, class.
Bye. Thank you,
Goodbye
teacher.
and thank you,
Goodbye.
teacher.
Thank you, teacher.